Hello everyone, welcome. This tutorial is presented by DSC Charles VB. In this tutorial, we're going to see trigonometry, mathematics. So these are the different sections which are going to be involved with trigonometry. We have main trigonometry ratios, illustration of trigonometry ratios, trigonometry for special angles, and all of this. So, trigonometry. You need to know that in ancient Roman, trigonometry is one of the main important features or one of the main important chapters which is involved with angle measurement and how to consider this angle with life aspects. If you have a circle in front of you, you need to quantify each of the points of the circle in front of you. Now, how do you do to quantify these points? Why difficult? We know that the main method of quantifying points in a plane or in space is by using Cartesian planes or by using Cartesian functions. But this becomes very difficult when you want to involve with circular surfaces. So now, when you want to quantify this type of surfaces, you mostly use the radius from the center of the circle and we use the angle theta. And very good and important things which are involved with the quantifying, how to quantify this angle, are going to be trigonometric ratios. This is a brief introduction into trigonometry. You need to know that there's always center in a certain circle with a radius. So if you want to have a quantification of each of the points of that circle, you can use the angle and the distance from the center, and that is with respect to polar coordinates and with Cartesian coordinate. So these angles, the measurement of angles and all this is going to bring us to our next section, the main trigonometric ratios. Now you need to know that in trigonometry we have main trigonometric ratios, and the main one, we have the first three main ones, which are the sine, cosine, tangent. So these are the three main trigonometric ratios. After having the three main trigonometric ratios, you are going to have their inverse. They are also the main ones, but they are not as main as this one, if I can say so. So the other three ones, you have the cosecant, you have the secant, and you have the cotangent. Now the cosecant is the inverse of sine, secant is the inverse of cos, and cotangent is the inverse of tangent. A simple way to identify this is just to take the third letter. You see that cot, the third letter of this word, is T. That third letter is going to be inverse of the one which has T here, and that's the tangent. So cot is going to be 1 all over tangent. Now you come here again on secant, see the third letter. The third letter here is C, and C corresponds to C on cosine. So secant is 1 all over cosine. And you still come here on cosecant. You see the third letter. The third letter here corresponds to sine. So cosecant equals to 1 all over sine. Now, illustration of these trigonometric ratios. Now, if you have a certain right angle triangle, this triangle is a right angle triangle, and the right angle triangle is characterized as having an angle which is 90 degrees, and the opposite to the angle of 90 degrees is going to be the hypotenuse. Now close to the angle of measurement, you're going to have an adjacent, and the opposite to the angle of measurement, you're going to have an opposite O. Now by convention, you need to know that the sine, when we say sine of this angle theta, is going to be the opposite here all over the hypotenuse, which is the opposite to the angle of 90 degrees. cosine of theta is going to be the adjacent all over the hypotenuse, and tangent is going to be the opposite all over the adjacent, as shown here. Now again, you need to know that opposite all over adjacent is the same as opposite over adjacent times hypotenuse all over. So the hypotenuse here and the hypotenuse here can cancel. Now opposite, so this one is similar to this, so there's only a small change just by addition of hypotenuse up on the numerator and on the denominator. So now when you have this, you see you need to know that now tangent here is opposite all over adjacent times hypotenuse times hypotenuse. Now opposite all over hypotenuse is same as sine, and hypotenuse all over adjacent is same as 1 all over cosine. So this implies that tangent is a sine theta all over cos theta. Now cosecant is 1 all over sine theta. This is by convention, and that's going to be the hypotenuse all over opposite. The second is 1 all over cosecant is 1 all over sine theta. Second is going to be 1 all over cos theta, and that is hypotenuse all over adjacent. And cot theta is 1 all over tangent, that is adjacent all over opposite. Now let's come back to the next portion. Now the trigonometry of spatial angles. Now you need to know that there are certain spatial angles to put in mind that they have some trigonometric values. These angles are going to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 and 360. So you need to memorize all these trigonometric ratios. You need to memorize the sine, the cosine, and the tangent of all these different angles. So this is what you need to put in your mind. Now the sine theta, sine 0 is always, when you need to memorize that sine 0 is 0. So there's a proof for this, but it's not going to be shown here for you to have simplicity. Sine 0 is going to be 0, cos 0 is going to be 1. And this will be seen when we are going to involve with the graph of sine and cosine in the next letter sections. And tan 0, we said that the tangent above here is sine of the angle over cosine of the angle. And now the sine of 0, see that is 0, cosine of 0 is 1, so 0 over 1 gives 0. Now again, the question to put in our mind is that the sine of 90 is 1 as seen on the graph below, and the cosine of 90 is going to be 0. Now 1 year, the tangent of 90 will be sine of 90 all over cosine of 90, so it will be 1 all over 0. So we see that there are certain points where the tangent does not exist, and that is infinity. You are going to see that in the later graphs, as you're going to see graphs of the trigonometry ratios. So now with this one, we've seen how to visualize the trigonometry ratio of the degree of 0 degrees. So again, when you want to know the value of trigonometry ratio, you must always put a second point in mind, that the trigonometry ratios exist between -1 and 1. So if your value that you have is out of this range, just know that it's false. So your trigonometry ratio of sine and cosine always exists between -1 and 1, but in case of tangent, because we said that 1 all over 0 was infinity, so the limit of tangent will be from -infinity to +infinity, including all the values inside, as we are going to see in the graph below. Now this diagram will be used in order to calculate the trigonometry ratio of 30 degrees and 60 degrees. So we are going to take this first triangle. This triangle is an equilateral triangle, and with a triangle, the sum of the different angles give 180 degrees. Again, equilateral triangles, characteristics of equilateral triangles is that an equilateral triangle has the same side, the length of the sides are going to be equal, and the angles of the equilateral and triangle are also going to be equal. Now, let's say I consider my length of the side to be 2 everywhere, and now I know that 180, since the sum of all the angles is going to be giving 180, 180 divided by 3, because I have 3 angles, going to give you 60. So here you are going to have 60 degrees all around. So what I'm going to do is to calculate the different trigonometric ratios of angle 30 degrees and angle 60 degrees by using these triangles. Now, I slightly do the conversion of the triangle by placing a vertical line as such, and the length of this vertical line is taken to be h. When I divide this triangle now into 2 halves, you see that the angle 60 degrees is going to be split into 2 halves. At this portion, you're going to have 30 degrees. The length 2 is going to be split into 2. At this portion, you're going to have 1, and this portion, you're going to have 1. So here still remains 60 degrees, and here is going to be 30 degrees. So you're going to realize that the cos of 30, so you see here, now you first have to calculate for h. The h at this portion here is the length of the vertical height. So we have h here. To calculate h, you need to use Pythagoras theorem, and Pythagoras theorem states that when you have 2 sides, A and B, with a hypotenuse C, the hypotenuse C is going to be equal to the square root of A squared plus B squared in a triangle, which is right angle. So now in this case, you see that this is one side, and 1 here is also another side with the hypotenuse 2. So you see that h in this case is going to be equal to the square root of the hypotenuse squared, because you have to put this in the equation. You are going to square this side, put a squared plus b squared. So since h now is one of the sides, you are going to place it the main part of the equation. So say h is going to be equal to the square root of the hypotenuse squared, 2 squared, minus 1 squared, and you are going to have the square root of 3. So here you are going to have square root of 3. Now, the sine of 30 degree is going to be the opposite to the angle of 30 degree, and this is 1, all over the hypotenuse. So sine of 30 degree, the value is half of 0.5. The cos of 30 degree is going to be the adjacent to the 30 degree, and this is the square root of 3 we've calculated, all over the hypotenuse, which is 2, and this gives you the square root of 3 all over 2, which is 0.86. The tangent of 30 can be taken as the sine of 30 all over cosine of 30, or it can still be taken as opposite all over adjacent. The opposite here is 1, the adjacent here is root 3, so you are going to have 1 all over root 3, which is going to give you, when you multiply below by root 3 and you multiply above by root 3, you are going to have root 3 over 3. Or you can still take it as sine of 30 over cosine of 30, which is going to give you half all over 2, and still give you root 3 over 3. Now sine of 30, now sine of 60 degrees. Let's come back here. We have 60 degrees here. So 60 degrees, the opposite to sine, you see that is opposite all over hypotenuse. The opposite to 60 degrees is going to be h, and that h is calculated below here as square root of 3. So it's going to be sine of 60 is going to be square root of 3 all over 2 opposite all over hypotenuse. So we come here, sine of 60 degrees is going to be square root of 3 all over 2, which is going to now give you 0.86. Realize very well that here for cos of 30 you have 0.86, and now for sine of 60 you have 0.86, the same value. The values of sine and cosine are always going to be similar at a certain differentiation of 90 degrees. You need to realize that the cos of 0 is 1 and the sine of 0 is 0. But when you do a differentiation by 90 degrees, now you do the cos of 90 is going to give you 0, and the sine of 90 is going to give you 1. So from this, you always see that there's going to be a differentiation anytime you have a cos of 30 and this of 60, and when they are separated by angle of 90 degrees, the cos and the sine, they are always going to give you the same value. From this, we see that there exists a relation between the cosine and the sine, and that relation of cosine and sine is going to be cos theta equals to sine of theta plus 90 degrees. So that's the equation of that's the relation between cosine and sine. And this relation, we are going to see them when we are going to involve in the graphs below. So now, coming back, we have the tan of 60 degree. Tan of 60 degree, we see come back tilts to 60 degree. We have opposite here, the square root of 3. We have adjacent 1. So tan of 60 is going to be opposite square root of 3 all over 1. So we are going to have the root 3. Or you can still say sine of 60 over cosine of 60, which is going to give you still root 3. So that is how to calculate the trigonometry ratio for the angle 30 degree and angle 60 degree. Now, in order for you to calculate trigonometry ratio for angle 45 degree, what do you do? In this case, you're going to involve with a square, and with a square, we know that the sides of the square are always the characteristics of the square. We have two main characteristics of the square. The first characteristic of the square is that all the sides are equal. And the second characteristic of the square is that all the angles are equal. And the next thing to put in mind is that the summation of the angles in the square is the double of that in the triangle. From here, we see that a square consists of two triangles. Initially, we've seen here that the triangle, in a triangle, the summation of the angle gives you 180 degrees. But below here, we see that a square consists of two triangles. Now, the summation of all the angles of a square is going to be the double of the triangle. That is 2 times 180. So here it's going to be 360 degrees. Since the characteristic of a square is that all the sides are going to be equal, and in this case I've taken the side to be 1, 1, 1. And the next characteristic is that all the angles are equal. Now we are required now to find the different angles of the square. So in order for you to find each of the angles, you need to say that 360 divided by 4. So to have each of the sides, and 360 divided by 4 gives 90. So each angle of a square is going to be 90 degrees. We are going to convert this square now to form two triangles, and these triangles are going to be right angle triangle because one of their angle is 90 degrees. We are going to involve the triangle on the right hand side. If I split this square with a diagonal line whose distance I call d, you realize that I will split them into two squares. So I'm going to split this angle 90 degrees into a half of 45 degrees here and 45 degrees, and I'm also going to split it into a half of 45 degrees. Now we see here that so the cos, we have the sine of 45 degrees going to be, we said by convention, sine theta is opposite to the angle of measurement all over the hypotenuse. Cos theta is adjacent to the angle of measurement all over the hypotenuse, and tan theta is opposite to the angle of measurement all over adjacent. Now, here in this case, the cos theta is going to be the opposite, which is 1, all over this hypotenuse d. Now, how do you calculate the hypotenuse d? We are going to use Pythagoras theorem. Pythagoras theorem is used with right angle triangles when you have two sides a and b, and d is going to be the hypotenuse of the right angle triangle. and the hypotenuse is the angle opposite to the angle 90, is the side opposite to the angle 90 degrees. So we're going to have now d is equals to the square root of a squared plus b squared, a is 1, b is 1. So we are going to have the square root of 2. So you have d. So now the sine of 45 is going to be 1 all over root 2. It's going to give you root 2 all over 2. Cos 45 is going to give you, now in this case you're going to have adjacent, which is 1 all over hypotenuse, which is still to the square root of 2. So 1 all over root 2 gives you root 2 all over 2. So this is the cosine and sine. Now the tangent now is instead going to be opposite all over the adjacent. Opposite here is 1, adjacent here is 1. So we have the tangent of 45 gives you 1. Now you can still see tangent equals to sine of 45 all over cosine of 45, and you still have it. Now the next thing we are going to involve with trigonometric ratio are the quadrant of the three main trigonometric functions. You need to know that in a Cartesian plane of x-axis and the y-axis, in this Cartesian plane there exists 4 quadrants. The first quadrant by convention is located here. The second quadrant by convention is located here. The third quadrant by convention is located here, and the fourth quadrant is located here. Now, when you have values of trigonometric ratios located in the first quadrant, you need to know that all of the trigonometric ratios are going to be positive. When you have values of trigonometric ratios located in the second quadrant, it is only the sign which is positive in the second quadrant. In the third quadrant, it is only the tangent which is located which is positive in the third quadrant, and in the fourth quadrant, only the cosine which is positive in the fourth quadrant. So let's come with some brief explanation. If you know that the angle located now in the first quadrant, are located between 0 degree and 90 degree. So if an angle is between 0 degree and 90 degree, the sine of that angle is going to be positive. The cosine of that angle is going to be positive. The tangent of that angle is going to be positive. And this is why we write here A to mean all the trigonometric ratios are positive in the first quadrant. Now, in the second quadrant is located between 90 degrees and 180 degrees. So when you need again to know that angles are always taken with respect to the positive x-axis. So when you have angle taken, so this angle is going to take it from positive x-axis, and this is 90 degrees from here to here, and the angle from here to here is going to be also 180 degrees. So the second quadrant is located between 90 degrees and 180 degrees. Now we need to know that S is written here to mean the sign is only positive. So if I have the sign of angle between 190 degrees and 180 degrees, it is only the sign of angle between 90 and 180 which are going to be positive. If I have the cosine of 90 to 180 degree angle, I am going to have a negative. If I have a tangent of 90 to 180 degree angle, I'm going to have a negative. The third quadrant is located between 180 degree and 270 degree. So it's only a tangent of angle between 180 degree and 270 degree which are going to be positive. The sine and cosine of this angle are going to be negative. And lastly, the fourth quadrant is between 270 degree and 360 degree. It is only the angle between it's only the cosine of the angle between 270 degrees and 180 degrees which are going to be positive, and the rest are going to be negative. Again, the movement of angle from here to this position is similar to movement from in the x-axis location. So Angle 30 degree is measured from the x-axis going upward as such in an anti-clockwise direction. Angle 30 degree is measured, so the positive angles are measured in a clockwise direction. Now the negative angle are measured now instead in the negative clockwise direction. Now a certain trigonometric ratio, a certain equation is going to come into place because of this quadrant method, and that trigonometric equation is going to be the cos of theta is equal to the cos of negative theta. I'm going to give you the reason. The reason from this quadrant method is that you see here that the cos of an angle taken here, angle which are taken from x-axis going in the clockwise direction, are positive angles, and angles which are taken from the x-axis going to a negative in the anti-clockwise, here is the anti-clockwise direction and here is the clockwise direction. Angles taken in the anti-clockwise direction are positive, and angles taken from positive x-axis in a clockwise direction are going to be negative. Now you see that the angle, if I take cos of 30 degrees, you see that cos of 30 degrees at this position, when you have here, you are going to have, you see that here is all, so the cosine is going to be positive. And now we have the cos again of negative 30 degrees. You see that here the cosine is still found in the fourth quadrant, so of negative angles is still going to give positive. So this, and when you are going to add up with this other quadrants, you are going to realize that the cos theta is equal to the cosine of the negative theta. That's the summary. Now this quadrant method is going to help us to find for the different solution of angle for different trigonometric equations, as we're going to see below. Now there are other trigonometric equations that you can find also by using this quadrant method. Again, if I ask you to calculate the sine of 120 degrees, now what are you going to do if you are asked to calculate the sine of 180 degrees and 120 degrees without using a calculator? So in order for you to calculate the sine of 120 degrees, you need to know that 120 degrees measurement is from positive x-axis anti-clockwise to this location, and it's going to be located on the second quadrant. We know that since the sine, it already implies that our answer is going to be positive because sine is positive in the second quadrant. The next thing again to put in our mind is, now when we have the sine of that answer, we need to find the magnitude of the answer of 120 degrees. Now again, trigonometric ratios occur in phase. When you are going to see the sketch of trigonometric ratios, you are going to see that the trigonometric ratios are always the same for particular phases, and they are same in the range of 0 to 360 degrees. Now you see here that the sine is you see that sine of 120 degrees is already positive. Now let's find the magnitude. In order for you to find the magnitude, we are going to find an angle which is located between 0 to 90 degrees from the negative x-axis. So we are going to see here, and that angle is going to be 120 degree minus 180 degree minus 120 degree, and that's going to give you 60 degrees. So the angle there is 120 degree, and from here to here is going to be 60 degrees. So that angle is going to be 60 degrees. Now the magnitude of that angle is going to give you the square root of 3, the magnitude of sine 60. Now the value from negative x-axis is going to give you square root of 3 all over 2 as calculated above. Now question: the sine of 60 is going to be the magnitude of sine of 120 to 120 degrees, but the sine of 60 is going to be the magnitude of sine of 120 degrees, but the sine of 120 degrees is not going to be this positive. So in order for you to have the sine of sine 120 degrees, you must find the quadrant method. So this quadrant is in order for you to know the sine of each trigonometric ratio. At this portion, you see that the sign is going to be positive. So you just come and find that particular value by doing 120 minus 180 minus 120. You're going to have 60. Since you're going to have 60, now you say that the sine is located in second quadrant and 120 is located in second quadrant. So it implies that sine of 120 is going to be positive root 3 over 2. Now, cosine of 60 we've initially calculated, that's going to be half. Now, tangent of 60 is initially calculated to be root 3. Now, the sine of 120 is positive square root of 3 all over 2 because sine is only positive, is the only one positive in the second quadrant. Cosine of 120 is negative half because cosine is negative in the second quadrant and tangent is negative 2. Again, if you are asked to calculate the cosine or the trigonometric ratio for the angle 330 degrees, the first thing to do is to find an angle between 0 and 90 degrees, which is going to be either from the positive x-axis or the negative x-axis. So in this case, we are going to take it from the positive x-axis. So we say 360 degrees minus the angle 330 degrees is going to give you an angle as such, and this is going to give you 30 degrees taken in the anti-clockwise direction. Now, when you have this 30 degrees, we are going now to find the magnitude again of each one by using 30 degrees. So sine 30, you know it's half. Cos 30 is going to be root 3 over 2, and tan 30 is going to be root 3 over 3. Now, the next point to do is now to find the sine of each one. So you say cos of the sine of 330 degrees is going to be negative because it's only cos which is positive in the fourth quadrant. So the answer will be sine 330 degrees equals to negative half. Cos 330 equals to negative root 3 over 2, and tan 330 equals to negative root 3 over 3. Now, the next point we are going to involve is how to measure angle with radians. You need to know what are radians. Point number 1, radians are values or the unit used in order to measure circumference and other characteristics of circles. Characteristics of circles are circumference and area, with the area of sector and all the likes, as you're going to see below. All these characteristics are measured with the value radians. In radians, pi, which is equals to 3.14, corresponds to the value of 180 degrees. Again, 2 pi, which is equals to 2 times 3.14, corresponds to the value 360 degrees. Now, in this section, conversion from radian to degree. In order for you to convert from radian to degree, the first point to do is to say that initially you say that pi corresponds to 180 degrees. Now, on this side, you have angles in radian, and on this side, we have angle in degrees. So we are going to say that theta in radians is going to be the theta, it corresponds to theta in degrees. So now, by doing cross multiplication, you do this times this divided by this. So theta now in degrees is going to be 180 degrees times theta in radian all over pi. So this is how to find your angle, to change your angle from radian to degrees. Now, if you want to convert angle instead from degree now to radian, the thing to do is to put on this side 180 degrees and say that it corresponds to pi. And on this side is going to be theta in degrees, going to correspond to theta in radians. So theta in radians is going to be, you could cross multiply. On this side you have theta in radians equals to pi times theta in degree. You divide by this opposite one, 180 degrees. So that is how to convert from radian to degree and degree to radian. So examples can be given to you. Example, convert the angle 360 degrees to radians. If you want to convert angle of 360 degrees to radian, first thing to do is to put 360 degrees here. So 360 degrees divided by 180 times pi. So this 180 in 360 gives 2. So the average is going to give you 2 pi. Now, measure your angle with radians. So now in this section, the next point is going to be characteristic of circles. So you have a circle above here, and you need to know the different characteristics of circles which are going to be involved. The first characteristic of circles is going to be the circumference, and the circumference is the distance required to move all around the circle. Second characteristic is the area of the circle, and the area of the circle is the area bounded all in the circle. The third characteristic of circle is the arc length, and the arc length is the length from with respect to which is enclosed between two radius. So the arc length is moving from here to here. Next point is area of the sector. The area of the sector is the area enclosed within two radius and from a certain angle. So let's say this is angle theta 1. The area of the sector is enclosed between this radius and this radius all through the arc length. So the area of sector is all this. The next one is area of the segment. Now you need to put in mind that this on this part you have area of sector, and here the area of sector is mainly shown here. We have area of sector here. The arc length is here. Now the area of segment, you need to know that there exists two segments. You have a major segment and you have a minor segment. If you have a sector as such, and then you draw a line in a horizontal line in this sector, you are going to have two segments as shown here. Let's say you have an angle theta separating the which is found between this sector here, and now you draw a line here, a diagonal line from here to this point here. So you realize that when you have drawn this line, you realize that you are going to split it now, the sector, into two portions. The portion which is larger here is going to be the major sector, and the portion which is smaller here is going to be the minor sector. So here at the point where you have area of triangle is similar to area of the major sector, and here where you have area of segment is similar to area of minor sector. So these are the different characteristics of the circle. So now how do you calculate the different characteristics of a circle? So calculation of circles characteristics. We start with first calculation, which is the circumference. The circumference, we should memorize the formula for calculation of circumference, and that formula is C is equals to 2 pi radian. Now, point to note, when you want to calculate different characteristics of circles, you must make sure that upon multiplication with angles, the angles must be in radians. First point. And the second thing that you must make sure is that when you are calculating the trigonometric ratios of this angle, you need to convert them into degrees. This is what shows the importance of this section. How to convert from radian to degree and degree to radian. It's going to be used here. Need to note that when you want to convert from one, you need to know that when you want to multiply the different angles, when you want to multiply an angle with distance, you must use the angle in radian. The radius here is a distance. You are multiplying now the angle pi with that distance, and when you are multiplying with that distance, you use the angle in radians. In this other case, A of circle, the pi must be taken as 3.14 in radians because you are multiplying times the distance, the radius. But now, when you want to use the trigonometric ratios of these angles, we are instead going to use the angle now in degrees. Example, the sine of the theta. Here, sine of theta is going to, theta now is going to be used in degrees. But when you multiply with distance, you use theta in radians. So now, you see here, so now the next point is to find the arc length. Initially on this diagram, we've seen that the arc length was this length here. And this length here, enclosed within the two radius, is similar to the circumference, but in this point, the circumference is due to the total length, the total movement. So in order for you to cover the circumference, you need to move by an angle of 2 pi or 360 degrees. But for you to cover an arc length, you need to move an angle of theta. So this is why it's going to bring you to this formula. So this, you have 2 pi, the whole rotation of the length is going to give you the circumference is 2 pi r. And now when you move a certain rotation of theta r, rotation for the arc length, you are going to have L. So L is going to, you're going to cross multiply, you're going to have pi in rads times 2 pi all over 2 pi. So this is what makes L to be r theta in rads. I make sure that you see that theta, when you multiply with a certain distance, it should be in radian. Now finding the area of sector. Again, coming to this diagram, the area of the sector is similar to the area of the whole triangle, of the whole circle, but in this case, the area of the sector is taken within a certain angle theta, while the area of the whole circle is taken within the whole angle 2 pi or 360 degrees. So coming back to here, find the area of sector. So you have 2 pi will correspond to a total area pi in pi radius square, and theta in radian is going to, so this is the area of circle pi radius square, and theta in radian is going to correspond to the area of sector. So area of sector is going to be the theta in radian times pi radius square all over 2 pi by cross multiplication. So you are going to have area of sector which is going to be half r squared theta. So this is the value for area of sector. Now let's say you want to find now the area of the segment. You have here the major segment and here the minor segment. Here you have the radius and here down you have the radius. Let's say they are enclosed within an angle theta. Now how do you calculate the area of the major segment? See that the area of this major segment is going to be a triangle. And number 2, so to calculate the area of the major segment is similar to calculate the area of triangle. Now area of major segment, you have theta here So if I want to calculate A of major segment, I should calculate A of triangle. And now A of minor segment is going to be the area of this whole sector that we have already calculated. We have the formula here, minus the area of the major segment. So now, first one, you need to calculate A of major segment for us to have A of minor segment. A of major segment now, you need to know that it should be half base times height, because this is the general equation for the area of a triangle. So now let's say I take my base to be this and my height to be this. So the base is this and this is a radius, and let's say this is the height. The angle is found here and this is theta. Now when this is theta, as I am drawing this line from this point to this point, you see that I'm going to split here this line into two halves. I'm going to split here with, now this is going to be a right angle triangle. So this triangle here will be a right angle triangle with an angle here measured to be theta. So the sine of theta here is going to be opposite here. This, I'm trying to find this height, though this opposite here will be the height all over the hypotenuse, and this hypotenuse here is the radius. So the height now, since it is opposite, sine theta is height all over radius, so it implies that the height is going to be the radius times sine theta. Now I make sure that you see that the theta should be in degrees. So here I said convert the to degrees to find the answer. When you want to find the sine or the trigonometric ratios of angles, you must make sure that you convert them to degrees. But when you want to multiply the angles with distances, you make sure that it should be in radians. So we have h is equals to r sine of theta in degrees. So area of major segment now is the base times height all over 2. Now the base here, you can see the base is radius. The height, you've calculated the height to be h equals to r sine theta. So you have r times r sine theta in degrees all over 2. So area of major segment is half r squared sine of theta in degrees. Now the area of minor segment, as you can see here, is the area of the whole sector here minus area of major segment. And area of whole sector was half r squared theta. And area of major segment is half r squared sine theta now in degrees. So we are going to have area of minor segment equals to area of sector minus area of major segment, which is going to be half r squared theta in radians because of multiplication with a distance, minus half r squared sine theta in degrees because we are doing the sine, the trigonometry ratio of the angle theta. So this is going to give you half r squared into theta rad minus sine into theta in degrees. Sine and cosine rule, Heron's formula, and area of triangle using angles. So this is the next section. At first, we're seeing the characteristic of circles. Now here we are going to see characteristic of the triangle. The triangle main characteristic is the sides, and you have the sides, you have the angles, and you have the area, with also the circumference. The circumference is not so of known or circumference is not so of important value. The circumference of this triangle is going to be a plus b plus c. Area we already know is going to be half base times height. That's general formula. But if you are only given an angle, we are going to use the Trigonometric method, as we're going to see in the following section. To start with, we're going to start with the sine rule. The sine rule state that, let's say that you have angles here with this different triangle. So when you have this triangle, this angle A is going to have an opposite side A. This angle C is going to have an opposite side C, and this angle B is going to have an opposite side B. The sine rule state that the sine of the angle A divided by its opposite side A is also going to be equal to the sine of the angle B here divided by its opposite side B, which is going to be equal to the sine of angle C divided by its opposite side C. So if you are given two angles in equation and you are given only one side and you are asked to calculate the opposite side, then you can use the sine rule. Example, if I'm given the angle A and I'm given angle B, I'm giving angle A to be 30 degrees, I'm giving angle B to be 60 degrees, I'm giving the side of B to be 3 centimeters, and they ask me to find the side of A, I'll use the sine rule. I'll say the sine of this 30-degree angle A, all over A unknown, is going to be the sine of the angle 60 degrees here, all over B, which is 3. And I'm going to place A as a main factor. So A now is going to be B sine of the sine of 30 degrees divided by sine of 60 degrees. And we know the sine of 30 degrees to be equal to half. Now sine of 60 degrees will be equal to root 3 over 2. You multiply all these division by 3. And you're going to have your answer of sine A. Now, the cosine rule. The cosine rule states that if you have only one angle and you have two sides, but you want to calculate another side, then you use the cosine rule. So let's say I have this side A and I have side B, but I am required to calculate for side C when I'm also given the angle C here. So you see that this formula is going to apply, and this is a formula for cosine rule. So the C squared is going to be A squared plus B squared minus 2 into AB cos of, so minus is going to be minus of 2AB cos of, now I'm going to put the angle of C here. It's going to be C squared equals to A squared, the side A squared plus B squared minus 2AB cos of angle of C. So let's say this one is 1 centimeter and this one is 2 centimeters. I'm asked to calculate for C when the angle here is 60 degrees. So what I'm going to do, I'm going to say C squared is going to be equal to 2 centimeters squared, 2 squared, plus 1 squared minus 2 into 1 times 2 cos of 60. And know that the cos of 60 is half. And when I do this, I have C squared. So I'm going to say now that C is going to be square root of all the value that I've calculated. So this is a cosine rule, and the cosine rule can still apply depending on the opposite angle you have. If you are instead given the side B and side C and you are given the angle A, you must make sure that it is A, the opposite angle to the side that you are given, for you to place it as the main factor of the equation. In this case, the angle that was given was C and the opposite side is C, so that's why C is placed as the main side of the location. Here, if you are given angle A, the factor that's going to be placed on the main side of the equation is going to be A here. If you are given angle B, the factor that's going to be placed on the main side of the location is going to be B. So let's say you are given angle A. If you are given angle A, instead it's going to be A squared equals to, we take the opposite sides now, you say equals to B squared plus C squared minus, I use still the opposite side, 2BC, now the cos of A. Again, if you are given angle B, what you do is going to be B squared equals to opposite side A squared plus C squared, and then you use the minus 2AC cos of the angle opposite to B, which is angle B. Now the next one is the Heron's formula. Again, coming back to this triangle, if you are given only the sides and you are asked to calculate the area without giving any angle, you are just giving the side as such, you know that normally area is calculated by using the half base, let's say I take the base to be this, and my height, the height will be drawn from this point to this point here. But you are given none of the angles. So to calculate the area, we are going to use the Heron's formula when you are given none of the angles. So the Heron's formula is stated as A of triangle equals to the square root of S into S minus A into S minus B into S minus C as such, where S is going to be A plus B plus C all divided by 2. So A of triangle is going to be square root of S all multiplied by S minus A into S minus B into S minus C, where S now is A plus B plus C all over 2. Now, area of triangle when you are given the angles. Let's say I'm given the angle A. You see that A of triangle is still half base times height. So you have here the height here, and here's the base. Let's say I take the height here, and here's the base. This angle here is angle A. So when I say here, the height can be calculated with respect to angle A, and this height, you see that the cos of the sine of A is going to be this height all over the hypotenuse here, C. So the height here will be the hypotenuse C times the sine of the angle A. So now in this case, you see that the base is B. So to calculate this triangle, you can use a half BC sine of A. So these are different formulas that can be used to calculate A of triangle. You're going to say half AB. When you use this side, always make sure that the angle you use is the side that you have not used here. So it's going to be a half AB, the side used. The angle here must be the side not used. So it is half AB sine C equals to half BC sine A. And here equals to half AC sine of the side which has not been used. Here A and C has been used. So sine of B. So this is the formula. The next part of this tutorial will be involved with solutions of trigonometric ratios. So, first point to put in mind is that when you want to find solution of trigonometric ratio, there are two main methods which are used. We have method 1, which is the quadrant method. You've seen the quadrant method above, and we said that there is a mnemonic which is used, and that mnemonic is cast in the fourth quadrant, starting from the fourth quadrant and going up to the third quadrant. See that? So let's come back to the quadrants. We have a cast. This is a mnemonic that is used. The fourth quadrant, the cosine is positive. First quadrant, they all are positive. The second quadrant, the sine is positive, and the third quadrant, only tangent is positive. So we have the quadrant method is going to be based on that. So when you want to calculate the different cosine and the angles for the sine, cosine, or tangent trigonometric ratios, you are going to use quadrant method, and the quadrant method is going to help you to find the sine, the sine of the value that of the trigonometric ratio that you've calculated, and also going to give you the magnitude, because you can take a reference value either from the positive x-axis or the negative x-axis, as we're going to see below. The next method, a simpler method, though I see it cumbersome, is the method of the formula method. Now, the formula method is that you just say that the angle theta, you apply formulas. You just see that angle theta for the sine trigonometric ratios, the angle theta is going to be equal to -1 or into n times PV. What is the PV? The PV is a reference value. Initially, when we've seen the sine of 120 degrees, the sine of 120 degrees, here the PV in this case is not going to be 120 degrees, but it's instead going to be 180 minus 120 degrees. That 180 minus 120 degrees is going to be now an angle with respect to a negative x-axis, and that is going to be 60 degrees. So the PV is going to be 60 degrees in this case. So we say theta is going to be -1 all into n PV plus 180 degrees n. Now question, what is n? So here you have to calculate, when you are going to see questions below, you are going to say that you have to calculate with respect, we are going to calculate many angles for a particular range. So you are going to have different ranges. If you are asked to calculate for a range, to calculate theta between a range of 0 to 360 degrees, we are going to place different values of n for you to have the values of theta. The n can be placed as 0, it can be placed as 1, it can be placed as 2, it can be placed as 3. So any integer value can place at n, such that when you place them, you are going to fulfill the ranges that has been given to you. If the range is given from -360 degrees to 360 degrees, you can start your n with negative values, such as -3, -2, -1, until you are found out of the range. So this is the value, the formula you use in order to calculate the angle theta for the sine trigonometric ratios. For cosine trigonometric ratios, in order to calculate the solutions, you use this formula: plus or minus PV plus 360 degrees n. Or if you are given a range in radian from 0, let's say from 0 less than equals to theta less than equals to 2 pi, we are going to use now the second formula, P plus or minus PV plus 2 pi n, where now n is still an integer which can be taken 0 to the negative integer value, -1, -2, -3, or it can be taken 0 to positive integer value 1, 2, 3, depending on the range that you're asked to calculate the value theta. For tangent trigonometric ratios, now the angle theta is going to be PV plus 120 degree n, or equals to this, depends on the range given to you. Now, let's say we have this example. So, in the interval 0 degree less than equals to theta less than equals to 360 degree, find the value of theta for sine theta equals to the square root of 3 all over 3. So you have this question. So the first thing to put, we are going to calculate by two methods. The first method was quadrant method, and the second method is the formula method. I like using the quadrant method because I am the one who is in the control of my solution totally. I totally control my solution, and if any error is performed, it's due to myself. So this is why I like using quadrant method. Now, the second method you can still use is the method of formula. That method of formula is a simple method. It's a simple method. But what I don't like with it is that you can easily do errors by substituting n and different values. So I prefer using the quadrant method. But depending on the student, you can choose any method to suit for yourself. So my quadrant method. So you have sine theta equals to the square root of 3 all over 3. You first start by saying this. So your PV will be, because you're asked to calculate the value of theta, the PV will be the reference angle, and that reference angle is always located between 0 degree to 90 degree, either from the positive x-axis or the negative x-axis. Now, you see again here that you have 35 degrees. So the sine, you say that PV is going to be sine inverse of the square root of 3 all over 3, and that is going to give you 35.26 degrees. Now, this is how to use the quadrant method. When you have your PV is 35.35 degrees. I'm going to draw an arrow from the center to this point. So you say that from here, from the positive x-axis to up here is going to be 35.26 degrees. Now, you see that the trigonometric ratio which is involved here is sine, number one. The second thing that you see again is that the sign of the value of this trigonometric ratio sine is going to be positive. So it implies that the angle, because you are asked to calculate the angle theta in the range of 0 to 360 degrees. Now, you see that in this range, you first have the value of 35.6. So in this first quadrant, the sign is going to be positive, and that is 35.26. Again, in the second quadrant, sign is still positive. So the angle from negative x-axis is still going to be 35.26. This angle from here to here. So now, from here now to this point here, from here to here, you are going to have a sine. So you see that here in the first quadrant and the second quadrant, sine is going to be positive. As such, here the values are positive. Now you see that the first value is going to be 35 degrees, and the next value will be the angle from here to here, and this angle from here to here is going to be 128 degrees minus 35.6, which is going to give you 144.75. Now you can decide to continue the rotation again for the second time. So you can say that the next value that is going to satisfy this condition here is going to be 35.26 plus 360 degrees. So 35.26 plus 360 degrees is going to be 395.26 degrees. But 395.26 degrees is out of range. This is why you are not going to place a value. So the values that you have found are just going to be theta equals to the values are going to be 35.26 and 144.74. This is why I like the quadrant method. Quadrant method, when you already analyze, I like analyzing my work. When I analyze the work, you see that you have 35 degrees directly and 144. You can easily write your answer. But the problem is with analysis. If you have any problem with analysis, it's better to take a simple method, which is the formula method. The formula method is the second one. And with the formula method, we've calculated the PV as sine inverse of the square root of 3 over 3, and that is 35.26. So now we are going to use the formula that is particular for the sine. And that formula is -1 all into n PV plus 120 degree n. Now we are going to first let n to be 0. The first value that's going to enter is 35.26. Next thing is that we let n to be equals to 1. When you still say that you have 144.74, and next thing you let n to be 2, you see that you have 395.26 as we had here, and this is out of range. So the values are going to be 35.26 and 144.74. Now, example number 2. If you are instead given to find the value of theta in the interval 0 degree to 360 degrees, now for cos 3 theta equals to the square root of 3 all over 2. This is cos 3 theta. Now for you to find for cos 3 theta, the first thing to put in mind that you need to calculate by 2 methods, but choose one method to calculate in your exam. I'm calculating here by 2 methods to show you very well. So we have the quadrant method. In order for you to calculate with the quadrant method, the first thing to put in mind is that since this is 3 theta here, cos 3 theta and not cos theta, you are going to modify this range for it to suit with the angle placed here, 3 theta. So to modify this, you're going to use this line. So you're going to do 3 times all this. So you're going to say 0 less than or equals to 3 theta less than or equals to 180 degrees. So now you see that this range is going to suit for 3 theta. Now you have cos 3 theta equals to the square root of 3 all over 2. Now this PV you are calculating is no more. At first here, you see that the PV that was calculated here was with respect to the theta, the value theta here. So PV, the reference angle, with respect to theta. But now, when coming to our next section here, we have instead cos 3 theta. So the PV now is instead with respect to cos 3 theta. And now, when you want to calculate the values, you need to know that the values that you have calculated are with respect to 3 theta here. So we are going to use this range also with respect to 3 theta. So we have cos inverse of root 3 all over 2, which is going to be the PV with respect to 3 theta, and that is 30 degrees. So now we speak about the cosine. We should make sure that it is the trigonometry ratio that we are involved with is cosine. And the sign of the trigonometry ratio cos here in this question is positive. We know that cos is positive both in the first quadrant and the last quadrant, the fourth quadrant. So we are going to see that the angle from here to here is going to be 30, and still the angle from here to here is going to be 30. So this angle here is 30, and this whole angle here is 330. So now you have these two angles, 30 and 330. Now to calculate, you are going to now base yourself with respect to this range. The first value of 3 theta that you're going to have is going to be 30. The next value is going to be 330, and then you are going to move by rounds of 360 degrees. So the first value is 30, and then I will turn again by 360 degrees. I'm going to have 330 plus 30. So you're going to have this. The first value is going to be for 3 theta. The first value is going to be 30. The next value is going to be 330. Then you're going to move by rounds of 360 degrees. So if we move the first round, you have 30 plus 360 degrees. You see half now for 330 degrees. You move for the first round here. So in this case, you move for the first round, you have 390 degrees, and now you come here, you move again for the first round. So you are going to instead have 330 degrees plus 360 degrees. Here again, for 30 degrees, you move for 2 rounds. You have 330 degrees plus 2 into 300, and for 330 degrees, you move again 2 rounds. All this is going to give you these different values. Now to calculate theta, and the last value here is 1050. You realize that if you calculate with 3 rounds now, you are going to have a value which is going to be out of your range of greater than 1080. So this is why I stop at 1050. So when you stop at 1050, you know that these are the values for 3 theta. And now the values for theta are going to be 3 theta divided by 3. I divide all through by 3 the values I've calculated. I'm going to have theta is going to be 10 degrees to 110 degrees, 130 degrees, and all this. And now a simple method to verify if your work is correct or not is just by substituting the different angle you found here in the initial question here. So this is a simple method for you to find if your work is correct or not. So if I use substitute 10 now back into this question, you are going to have cos 3 into 10, 30 degrees, and that is equal. If you substitute back this value 110 into this question, you are going to have this. So you try to substitute all the different values back into this question, and if it does not give you positive root 3 over 2, then you did an error in your question, and you need to start back and verify where the error is. Now, formula method. This is why I don't really like the formula method. With my quadrant method, you see that I've already analyzed by 3 lines, and then you have your work. Formula method, you can still do it. It's a good method, a very powerful method, but though it takes much more lines and much more n numbers that you have to consider. Now, in this case, still know that our PV was the cos inverse of root 3 over 2, which is equal to 30 degrees. So the formula now involved for cosine is going to be x equals to plus or minus PV plus 360 degree n. In this case, you see that x here is equals to plus or minus PV plus 360 degree n. But now you must consider that x in this case is no more as the first question where we had sine theta equals to square root of 3 over 3. In this case here, the the x now will be considered as 3 theta. The x here will be considered as 3 theta because it is cos of 3 theta. So it implies that 3 theta is equals to plus or minus PV plus 360 degree n. So when we have written this line, this main line here, then your equation is over. The next thing to do, when you have applied this formula by placing the 3 theta here, the equation is over because the next thing is to fill in the n. So you start with n0, you're going to have 30 degrees. You must make sure that it is plus or minus first because it is going to be either plus 30 and also going to be negative 30, but the question is negative 30 present between the range of 0 to 1080 degrees? Because here you must know that please, there's an error here. You should not consider again the range of 1080 here. So this you can consider it's not in the range of this one. So you have theta now, it's going to be equals to 30 all over 3. I'm going to have 10, but negative theta 30 is not in this range. Now you come back to let n equals to 1. So when n is equals to 1, you have 30 degrees is equals to, so when n is equals to 1, you have 30 degrees equals to, substitute here, you are going to have two values. Either when you have plus 30 degrees, it's going to give you, when you have plus 30 degrees, it's going to give you 390 degrees, and when you have minus, it's going to give you 330 degrees, and all of them are in this range. Since all of them are in this range, you have theta is equals to, you then open the brackets and you divide by 3. You're going to have this and this. Again, you let n equals to 2. You have 3 theta is going to be this, and these two are in this range. So you have theta is equals to 690 all over 3 and 750 over 3. So because here is 3 theta, when you divide all side by 3, you're going to have theta here. So it makes you that, so when you consider again n equals to 3, you have 3 theta equals to this. The first value that you're going to have is going to be 1050, and the next value is going to be 1110. But the 1110 is out of this range. This is why you're not going to consider 1110. So you are just going to consider 1050. So this is an error. So when you are going to have 1050 divided by 3, you are going to have this. So this you are going to have 350, and this is in all the range, all the values that are going to be involved in the calculation, and this is similar to the values you had in the Quadrant Method. Proofs involved with trigonometric ratios. So this is the next section. In this section, you should know how to prove the different trigonometric ratios. The first point, when you want to know how to prove trigonometric ratios, you must have memorized the initial proofs. These initial proofs are proofs that are by convention. This one is we are using a triangle in order to prove this, but this is out of scope of our tutorial because we want this tutorial to be as simple as possible. So the first proof to be memorized is sine squared theta plus cos squared theta equals to 1. It should be memorized. So, and from this you see that sine squared theta is equals to 1 minus cos squared theta, and from this you see that cos squared theta equals to 1 minus sine squared theta. Again, the cos A minus B, when you have a minus here for cos, so cos A minus B, you must make sure that first for cos you have cos and cos on one side, and you have sine and sine on one side. So for cos A minus B, you have cos A cos B, and you have sine A sine B. Now the problem is that with cos, when you have minus here, you must make sure that there's a positive sign here. With cos, I always take cos as a brief way to summarize in my head. I always take cos as being on the negative side. When you have cos of 90, you see that 90 is a big value. It's supposed to give something which is tangible, but cos gives, since I take him as a negative side, cos of 90 will give me 0. And also I take cos of 0. You see that normally 0 is something small, but cos makes it to be 1. So cos of negative sign. So anytime that you see negative here, you must make sure that it should be positive here. So cos of A plus B, you should make sure first that it is cos on one side and sine on one side, and the sign here should be the opposite of the sign here. So you have cos A cos B minus sine A sine B. Sine A plus B, sine is on the positive sign. Sine of 90 gives you 1, it gives you tangible value. That's true, that's correct. Sine of 0 gives you 0, that's also a tangible value. So sine is positive, it's not disturbing. So you see that the positive sign here is my positive. That's my way to memorize it. You have sine of A, sine also. Sine now, in order for you to see the magnitude, you know that sine is sine and cos together. So it's sine of A, cos of B, and then cos of the first one, cos of A, sine of B. Sine A minus B is sine of A, cos of B, minus cos of A, sine of B. Now from this one above here, from equation 1.6, you see that if I place theta here and I place theta here, so you are going to have sine of theta, cos of theta, plus cos of theta, sine of theta. So this is going to be, see, these are equal, so it's going to give 2 sine of theta cos theta. So from equation 1. So now we continue with the next one. We have cos of 2 theta equals to cos squared theta minus sine squared theta. So from equation 1.1 here, so we can calculate it from equation 1.1. So equation 1.1 is this. So cos theta first here, for cos 2 theta, you place it here. So you're going to have cos theta is going to give cos squared theta. So you're going to have this. Now, in order for us to find the tangent, let's just have a first proof on how to prove tangent of A plus B equals to tan A plus tan B, or like this. Now, in order for us to do this, you are going to have tan A plus B. You know that it is sine, the tan of an angle is the sine of the angle over cos of the angle. So the sine of A over B is going to be this, sine of A cos B plus cos of A sine B, all divided by this. Now you see that the cosine, this is positive, and here in the case of cosine, it's going to be negative. We come back, we say that when you divide all through by cos of A, cos of B, when you divide all the different values by cos of A, I divide the numerator by cos of A, cos of B, I divide the denominator by cos of A, cos of B, and this is make that the different constituent of the numerator and denominator are divided by cos of A, cos of B. I'm going to have this. When I divide this, I can cancel cos of B with cos of B. I'm going to have tan A. I'm going to cancel cos of A, cos of B. I'm going to have tan B. All over 1, this will cancel, minus, I'll cancel here. Here I'm going to have tan of A, I'm going to have tan of B. So this is pretty summarized, and this is the proof. And with the case of minus, the only thing I'm going to do, I'll not go again and do back the calculation. When you have tan of A plus B, this is similar with tan of A minus B, but the only difference is that at the side where you have here, you are plus, you are going to place here minus. So, and cos of A, you're going to place minus. Now you know that sine of A minus B is going to have a minus here, and cos of A minus B, you're going to have a plus here. This is why in this equation, instead have a minus here and a plus here. So there's no need to go back again to all the calculation when you have the minus here, because this is similar to this other one. Now, example. So proof sec square x all over tan x equals to sec x cos x. So now, the first thing to put in mind is that when you want to prove in trigonometric equations, you must make sure that you are starting from either the left hand side or the right hand side. Now, what are the factors that should make you start from either side? You must make sure that for you to prove, you must start from the side which is the longest. Number 1. So this is the first factor that you should put in mind. I must start from a side which is longer. Number 1. The second point to put in mind is that you should always start from a side which has a fraction. So when you want to prove in trigonometric ratio, the first point is that you should start from a side which is longest, and the second point is that that side must have a fraction. So now in this case, you see that this side has a fraction and this side is still long, but it does not have a fraction as such. So I prefer starting from a side which has a fraction than a side which is long for nothing. So it is better now here to start from the left hand side. Now the next thing to put in mind is that if you have a side that you are starting but you cannot attain the answer, the third point now that you have to add is that for me to prove, I need to divide. If I have started from the longer side and I didn't start from the side with the fraction, in order for me to change the side which is longer to a fraction, I must divide it by 1. And I will use the trigonometric ratio here. You know that 1 is equal to sine squared theta plus cos squared theta. So if you have used a side which is long, rather than having a fraction, you are going to divide it by 1. I'm going to use sine squared theta plus cos squared theta, and you are going to calculate. Else, whilst I prefer that it's preferable for you to start with the side which always has a fraction. So, example. In this question, you have squared x all over tan x equals to I'm going to start here from the left hand side. So this is going to be sec x times x sec x all over tan x. So before I start still, I must also visualize how the answer can come out from my mind. So when I visualize, you see I have this. Now when I have this, but tan x is equals to sine x all over cos x, I'll substitute it back here. I'm going to have this. I'm going to divide all through. I'll see that this and this are going to cancel. So I'm going to have sec x times 1 over sine x. So the answer is going to this give, and I've proved my question. So this is the main way for you to prove for trigonometric quantities. You must make sure that you always start with a side which is longest, and that side must have a fraction. Now the next section that you're going to involve is the curves of trigonometric functions. Now the first curve to need to put in mind is that this is sine curve. So this is sine curve. So the sine curve, here from this curve, now we can prove now the value that sine 0 is 0, and then cos sine 90 is 1. Now you see that you have 0 here, it's increasing on this side and then decreasing. You see that this is similar on this other side. This is the sine curve as such, and there are two main points to note. The sine curve, you have the x domain. The x domain of the sine curve is from, in this case, is from negative 30 degrees to 30 degrees between theta. Note also that the range of sine always exists between -1 and 1. So the y value is never going to be out of this range. It's always going to be between -1 and 1. So it is not possible if you take your calculator and you write the sine inverse of 2 is going to give you a math error, because it is not when you are doing the sine inverse, you are considering these ranges, and it is not going to be further from that. Now come back to cosine curve. The cosine curve is drawn as such. So from here we already see cos 0 to be equals to 1, and we see sine 0 to be equals to sine 9, we see cos 0 to be equals to 1, and we see cos 90 to be equals to 0. And the characteristic of the curve here is that it's starting from negative 360 degree to 360 degree, and it's going to be a cosine curve which has an interval in the y range of being -1 and 1. So the cosine always exists in this same range. So again, if you take a calculator and write the cosine of 50, cos inverse of 50, you are not going to have any answer but the math error. The cosine curve from the graph leads to sine curve by 90. So again, from this graph, when I see the two graphs, I see this graph and I see this graph, we see that cosine curve is in front of the sine curve by 90 degrees. So when I see this graph and this graph, the cosine curve is in front of this sine curve by 90 degrees. So the sine curve has to do 90 degrees for it to attain the cosine. This is why you can generalize a formula that we've already spoken above in the quadrant method, when we were saying the trigonometric ratios, some values for angles, values for special angles in trigonometric ratios. So we have cos theta is equals to sine into theta plus 90 degrees. So this is the general equation which can be used to summarize the two graphs which can be seen above here. Now the next point is a tangent curve. Again, we've seen already that sine tangent of 90 is going to be infinity, because sine 90 was 1 and cos 90 is 0. 1 over 0 is impossible, and that's infinity. So the characteristic of tangent curve is that it's going to start from 0. As it increases and attains 90, it's going to go to a certain limit, and that's the asymptote. Is the asymptote here. And also, as it's going to go to negative 90 degrees, also going to attain the limit, and that's the negative asymptote. So this is how the tangent curve move. So in this graph, the tangent curve has a domain of negative 30, 360 degree to 360 degree, and the range, I've taken the range of the tangent curve here is from negative infinity to infinity, so it continues to infinity. Other formulas used in trigonometry. So we've seen the first formula above. The next formula which are very good and used in trigonometry are the sine A and sine B. So we first need to memorize this formula. Sine A plus sine B equals to 2 sine into A plus B all over 2 cos A minus B all over 2. Sine A minus sine B equals to 2 cos into A plus B all over 2 sine into A minus B all over 2. We have cos A plus cos B equals to 2 into A plus B all over 2 cos of this, and we have cos A minus cos B equals to this. Now we are going to have a small proof on one of them. So in order to prove them, we are going to let that P is equals to A plus B all over 2 and Q is equals to A minus B all over 2. Now we say sine P plus Q is equals to, now we initially know that this formula is what was written above. So this is sine P cos Q plus cos P sine Q, equation 1. Now we know that P plus Q, we are going to substitute the values that we've left here. So it's going to A plus B all over 2 plus A minus B over that is going to give you A. So P plus Q gives you A. So we can summarize that sine A is going to be equals to this. And now sine P minus Q is equals to this, sine P cos Q minus cos P sine Q. Now P minus Q is instead going to A plus B over 2, and all this gives you B. So you can summarize again that sine B is equals to sine P cos Q minus cos P sine Q. Now when you come, we say that sine A now plus sine B, or sine P plus Q plus sine P minus Q is going to be sine A plus sine B, is going to give you sine P cos Q plus this, the first one, all plus the second one. So this and this are similar and they're going to cancel out. You're going to have 2 sine P cos Q. So now you know that P is equals to A plus B over 2 and Q is equals to A minus B over 2. So sine A plus B is going to be equal to 2 sine into A plus B all over 2 cos of A plus B all over 2. So this is similar with the minus. In the case of minus, you see that this is going to be negative here all through this. So this is going to be negative When the negative is going to enter into the bracket, you're going to have negative here and you're going to have positive here. So cos this and this are going to add to give you 2, and these are going to subtract to give you 0. So you're going to have this in this other case. And you can use a similar method for you to prove. You see that in case of cos A and cos B, you have cos on one side and you still have cos A minus, you have sine on other side. And this is similar with cos A plus cos B plus Q and cos B minus Q. So we are going to use the other method for you to prove for the cos. Now, the question is, where will I use this formula ever in my life? So it's very necessary for you to use this formula and they are going to apply in this next section. So finding solution of some complex trigonometric questions. So now we've seen that already we've seen how to calculate some complex trigonometric questions such as cos, so simple trigonometric questions such as cos theta equals to square root of 3/2, and we've already calculated cos theta equals theta equals to square root of 3/2. That one was easy. Now let's say you are given this question to calculate cos 8x equals to cos 6x and cos 8x plus cos 6x equals to 0 in the range 0 degree less than equals to x less than equals to 360 degrees. So what do you need to do here? So what I'm going to do is to use this method above in order for me to factorize. So I'm going to say that this is similar to say cos A cos B. So cos A cos B, I'm going to take this one as A and I'm going to take this one as B. And I'm going to say 2 into cos A plus B all over 2 cos A minus B all over 2. So my A here is going to be 8x and my B is going to be 6x. When I substitute, I'm going to have this value. So here I will say that either cos 7x equals to 0 or cos x is going to be 0. Now I'm going to proceed by the method, the simple method that you have seen above. Let's say the first case, we have cos x equals to 0. I'm first going to find the reference value and use my quadrant method. My reference value here is going to be PV equals to the cos inverse of 0. The cos inverse of 0 is going to be 90 degrees. Now I know that this is 0 and this is positive. So we are going to have 90 degrees, which is going to be found there, and I'm going to have 270 degrees. So 0 does not have a positive value or negative value. So all the quadrants that we find 90 degrees, then you must involve it. So you have 90 degrees and 270 degrees because of cos x. Now you continue again with cos 7x. Cos 7x, we are going to change the interval of this one now into 7. So we are going to multiply here by 7 or into, so we are going to have 0 less than equals to x less than equals to 7 into 360 degrees. So this is the maximal range. So what you are going to do now is to calculate now the different values in the interval for you're going to first calculate the PV for 7x, and that PV is going to be equals to 90 degrees still. Now when you are going to have 90 degrees, the next thing to put in your mind is to say that you're going to have 90 degrees and 270 degrees, and the next thing you're going to do is to do the different terms. So your first value will be 90, 270 degrees, as you have already considered here, but here in this case you're going to divide all through by 7 because it is 7x and not x as in this case. So you're going to have 90 degrees, 270 degrees. You're going to have again the next value will be 90 plus 360 degrees. The next value will be 270 plus 360 degrees. Then the next thing you'll do again is to do a second round, 90 plus 2 into 360 degrees, and 270 plus 2 into 360 degrees. Then you do a third round, you have 90 plus 2 into 360 degrees plus 200. You do that till you arrive the maximal limit of 7 into 360 degrees. So when you arrive at maximal limit, you then have the different values of 7x. When you have the different values of 7x, you then divide all through by 7 to have your values. And again, point to note, you need to put in mind that for you to calculate if you are correct or wrong, you need to come back to the initial question, and this is this cos x plus cos 6x. If you substitute all the values and you find that it's not equal to 0, then it implies that you had an error somewhere. Now, the next thing to put in mind is how to sketch curves of some complex trigonometric function. Here was how to find solutions on complex trigonometric equation, and this is a formula that we use. We use the formula that we've seen just above here. Now, how do you sketch curves of some complex trigonometric functions? Now, to sketch curve of some complex trigonometric function, you need to know that the curves will exist in the form of r sine into x minus alpha or r cos into x minus beta. Now, let's say you have expressions in this form. You are asked to plot curves of this form: a cos x plus b sine x. Example, if you are asked to plot a curve of the form 7 cos x plus 5 sine x, you're asked to plot that. What are you going to do? So in order for you to plot these curves, the first thing to note is to convert them into the format r sine x minus alpha, or to convert them into the format r cos x minus beta. These are the two formats in which you can convert the curves. And now you need to know that these formats are going to be similar, because cos theta and sine theta and sine trigonometric ratio are related by the function cos theta equals to sine x into theta plus 90 degrees. Now, in order for me to do this, the thing I need to put in mind is that I'm going to use this form r into sine x minus alpha, and when I do this, I'm going to expand it. I'm going to have r into sine x cos alpha minus sine alpha cos x, as such. When you expand, you have this, and now this is what we are going to have at the end. Now let's come back again to the new format, to our format at hand. The format of the equation will be given into this form: a cos x plus b sine x. So the cos x here will correspond to this. So r sine alpha is going to be our a from this part here, and here the sine x will correspond to r cos alpha. So r cos alpha corresponds to b. So here we have r sine alpha equals to a and r cos alpha equals to b. So here you have r squared sine squared alpha is equals to a, and you also have r squared cos squared alpha equals to b, because I multiply the both sides of the equation. So now say equation 1 plus equation 2, I'm going to r squared into this plus this is equals to this side plus this side, a squared plus b squared. Now when I bring out this part of the equation, I'm going to have r squared into this, and this equals to 1, so I'm going to have this. So my r is going to be equals to square root of a squared plus b squared. Now this is equation 1, and now I need to bring up into mind again that you have equation, when you want to find out the angle alpha here, you need to say equation 1 divided by equation 2. You have r sine alpha over r cos alpha equals to a all over b. So r sine alpha over r cos alpha is going to give tan alpha, and I'm going to say alpha is going to tan inverse of this. So the new expression of the equation a cos alpha plus b sine x is equals to, so it's going to this. This is a new equation that's going to be involved now. The graph now, in order for you to know now what is the graph that you're going to involve with, you need to put in mind that the new range, so we've seen above here the different characteristics of graph. We said that the graph exists with a certain domain and a certain range. Now you need to know that in this question you perform here, you convert of a format of a cos x plus b sine x into a format which can easily be drawn. So into a format which can easily be drawn, and this format is r sine x minus alpha. Now this r, what's the importance of this r? The r here is going to be important in finding the new range of values. Normally, you know that for the trigonometry, for the function sine x, you know that the 1 is found at the beginning. So for sine x, you have the range -1 less than or equals to sine x less than or equals to 1. So that's the interval in which sine x exists. Now, if you want to know now the new interval in which r sine x minus alpha is going to exist, you need to multiply now all through by r. When you multiply all through by r, you have a new interval in which they are going to exist. So that's -r less than or equals to y less than or equals to r. So this is a new interval in which sine x is going to exist. Now, the next point to put in mind is, again, what is going to be the x domain. Need to know again this point here, x minus alpha. What is the function of this x minus alpha? X minus alpha is used to shift the curve either to the left or the right. So this area is going to shift the curve up, and not going to shift the curve up and down, but it's going to expand the curve up and down. So by a certain value r. So let's say this r is 2. You see that the maximal value here is going to be 2 and the minimal value is going to be -2 instead of being 1 and -1. Now the x minus alpha, this alpha here is going to shift the curve either to the left or right depending on whether this sign is positive or negative. If at the end of the calculation you find that this sign here is positive, then there is going to be a shift of the curve to the left. And if at the end of the calculation you find that it is negative, then there is going to be a shift of the curve to the right. Example, you have cos theta equals to sine of theta plus 90 degrees. So let's say we take this example. So this example, we have cos theta equals to sine of 90 degrees. So now, with this example, you see that cos theta, we know that cos theta is equals to sine of theta plus 90 degrees. And now, we see from here that there is going to be a shift sine of 90 degrees. So this is the sine curve and this is the cos curve. In order for me to find this is the sine curve here and this is the cos curve. In order for me to have the cos curve from this sine curve, I need to shift this curve now to the left, because you see that this is sine of theta plus 90 degrees. So cos theta is sine of theta plus 90 degrees. That plus makes that to form the cos curve from the sine curve, need to shift the curve to the left. Now, if there was instead a minus sign, then you have to shift it instead to the right. So let's see another example involved with this. So in this case, you have sine x and we have the sine x minus 40. So sine x is drawn as such. Now, in order for you to find sine x minus 40, you need to shift because this is sine x, not this is sine x minus 40. Sine x minus 40. So in order for you to find sine x minus 40, you need to know that this graph is going to be shifted, not in this side, but in this other side here. Is going to be shifted to the right as such. The graph is going to be shifted to the right as such. So when it's going to be shifted to the right, so the graph is going to be shifted to the right as such. So as it's going to be, because of this minus sign, if it was a plus sign, it would have shifted to the left. Because of this minus sign, shift to the right. Since it shifts to the right now, we are going to have this new curve. See that it shifted slightly to the right, and I'm going to have this as such. Now, if you place 2 in front of this, you're going to have increase in magnitude here. So this is how to plot the complex trigonometric ratios. Now, inverse of trigonometric equations. You need to know that they are inverse to trigonometric ratios. When you have, example, if you have sine theta equals to a, cos theta equals to a, and tan theta equals to a. So in this case, theta is equals to sine inverse of A. Theta is also going to be equals to cosine inverse of A, and theta is also going to be tan inverse of A, and all these are written by convention. Now, the first thing to note here will be the graphs involved in inverse trigonometric ratios. So let's plot the graph of sine inverse of x, or arc sine x. So this graph here is just shown as such. So the limit of this graph is going to be in the interval -1 and 1, and they're going to stop here at 90 degrees. So this is the limit, and they're going to stop here 90 degrees as such. So the limit is going to be -1 and 1. We'll stop as such. Now, the characteristic of sine -x or arc sine are shown below. Here in this case, we have the x domain is not more in between -360 degrees to x to 360 degrees, but it's instead in -1 less than or equals to x less than or equals to 1. And now the range in this graph is going to be -360 degrees to or less than or equals to y less than or equals to 360 degrees. But we can see here that the graph stops at exactly 90 degrees. It does not continue. Here with the cosine inverse graph, the cos graph is going to stop still. It's going to stop here at 90 degrees, and here is going to stop somewhere at 180 degrees. So the cos graph stop the interval, the y interval is from 0 less than or equals to y less than or equals to 180 degrees. Now the x interval here, we see that it's going to be from -1 to 1. And the tangent curve is going to still start, is going to be having an x range of -10, 10. So the tangent curve continues when it goes from -infinity to infinity, because we've seen that when you want to find the arc sine curve with when you want to find arc sine curve with respect to the sine curve, you need to know that the inverse trigonometric curves are the trigonometric curves where the sides are inverted. In this case, when we consider above here, we see that the x domain is -360 degrees to 360 degrees, and the y range is going to be -1 less than or equals to y, or sine x less than or equals to 1. Now you see that this y range is now going to be the x domain, the inverse curves, and this one is going to be instead the y interval in the inverse curves. Now what happened is that in this case, when we come in this case of tan, we said that this the y interval of tan, the x interval of tan was going from -infinity to infinity. This implies that now the y interval of tan was going from -infinity to infinity. This implies that now the x domain, since it's an inverse function, the x and the y has inverted. So what happens is that this is going to go from a range of -infinity to positive infinity. And now, as with the y range, is now going to go now for a range of -360 degrees to 360 degrees. But from here we see that it stops at the level of 90 degrees, 90 and 90 degrees. So solving inverse trigonometric equations. So now, what are you going to do in order to solve inverse trigonometric equation? For you to solve inverse trigonometric equation, the first thing to put in mind is to always let a certain value to be equal to your inverse trigonometric ratio. Example, if you have this equation given to you, tan inverse of 1 minus x, you must always let a certain value, let's say x, to be equal to tan inverse of 1 minus 5. So let's take an example. Phi sine theta, given that theta is equal to the sine inverse of 3 all over 5 plus sine inverse of 5 all over 13. The first thing I'm going to do is to let x to be equal to this, and I also let y to be equal to this. When I've already let all this, I'll say now that sine x is going to be 3 this, because I'm going to place on this other side with 3 over 5, and sine y is going to be 5 over x. Now I have this to be equal to x and this will be equal to y. So I will now say that theta will be equal to x plus y. Now they are asking me to find sine theta. So I'll say sine theta is going to be equal to sine into x plus y. Now, what is sine x plus y? I'll use the right hand side order for me to calculate. So sine x plus y is equal to sine x cos y cos x sine y. So now we have sine x here, we have sine y here, but we don't have cos y, and we don't have cos y, and we don't have cos y, and we don't have cos x. So we should use figure 1.1 in order for us to calculate. So we come here now. So we say that this is figure 1.1. Let's say that this is y. So y, let's say y now, we know that y is going to be 5 all over 13. So sine of y is 5 over 13. That's what we know. So since we know that by convention, sine has the numerator as being the opposite and the denominator as being the hypotenuse. If we create a triangle, we are going to have this. Let's say that this is the angle y here. So the opposite will be 5 and the hypotenuse will be 13, and this will be the adjacent. The adjacent will be calculated as being the hypotenuse squared minus the square root of the hypotenuse squared minus the opposite squared. So you come here, this is adjacent, and this value gives a equals to square root of 14, and this gives you this equals to 12 cos of this and this. Now if I use figure 2, now in the second case, you know that sine x is equal to 3 over 2. The numerator is opposite, the denominator is 5, and that's the hypotenuse. I'm going to create now this new triangle with x found here. Since x now is found here, this is the hypotenuse, and with h equals to 5, this is adjacent, and the opposite is going to be 3 in this case of x equals to of sine x here. Now I'm going to do now the cos x is going to be the adjacent. The first thing to put in mind is to calculate adjacent. The calculation of adjacent will be similar. It's going to be square root of 5 squared minus 3 squared, and this gives you 4. So cos x now is going to be adjacent all over hypotenuse, which is equal to 5 here. So you are going to instead have 4, which is adjacent all over 5. So you have your cos x and you have your cos y. So here now you have the different value cos x and cos y that you can substitute. So when you substitute all these values, you're going to have sine theta equals to 3 all over 5. This is the sine x, this is a cos y. So now you substitute here, and here this is sine y, and this is cos y, and this is cos x, and this is sine y. All this, when you substitute, you're going to have sine theta is equals to 56 all over 65 equals to 0.86. So from here we've seen all the study of trigonometry, which was based on the main principles which were used on trigonometry. So these are the main principles used on trigonometry. We will summarize it as being with number 1, the main trigonometry ratio, illustration of trigonometry ratio, trigonometry of spatial angles, where we've said that spatial angles, their main spatial angles are sine, cosine, and tangent, with other subsidiary ones which are cosec, secants, and cotangent. So now we could have the measurement of radians, where you have seen the characteristics of circles and the characteristics of triangles. Here we have triangles, we have the different sine rule, cosine rule, Heron's formula that we are going to were involved. We also had solutions of trigonometry ratios that we've seen. We found the curves of trigonometry ratios and other formulas which are application, and we've lastly seen the inverse of trigonometry ratios. So from here we say thanks for kind attention, and please don't forget to like and subscribe to the channel Science Dreammaker, presented by the USA Child BB. Thank you.